Okay, here we go, section 8.2. This is integration by parts, just a new way to, new rule for integration. We experienced some of these issues during the year that we weren't able to integrate certain problems, and this is the way we're going to do some of those. So here we go. So these first three examples are just going to show you how you could possibly integrate someone with our old rules, but what happens when we get to this third example here, where some of our use substitution rules don't work. So for the first one, again, I'm going to go through these kind of quickly. Obviously, the integral for e to the x is e to the x plus c. So again, old rule works for this one. This one we can use substitution, let u equals x squared, du is equal to 2x dx, so du over 2 equals x dx. And again, that matches up with our x dx. So now when we integrate this, it's going to be a 1/2 integrate e to the u du. And that's going to be 1/2 e to the x squared plus c. But now we get to this third example. If we try to use u substitution, we get u is equal to 6x, and then we do du is equal to 6 dx. We have this extra x that's in the problem. Now, we could, now again it doesn't match up, but we could solve this one for, for x and get u over 6 is equal to x and try to do that substitution, but it's still not going to work out. Okay, and this is where this integration by parts is going to help us out here. All right, so integration by parts is best useful when it's the product of algebraic, but more importantly, transcendental functions, which are e to the x, ln of x, sine x, some of those functions. So here's three examples where integration by parts is going to be useful to use, and some of our other methods aren't going to work out. Okay, so integration by parts. It's based on a formula for derivative of a product, and again, it's integrands involving products. So I'm going to quickly derive this rule for you. I'm going to do it two ways. I'm going to do it in terms of f of x times g of x. And I'm also going to do it as u times v, just so you can see both methods, and we'll go from there. All right, so the first thing, it starts off as the formula for a product, a derivative of a product. So the derivative of f of x times g of x. All right, so if we took the derivative of that, it would end up being the derivative of the first times the second plus the first times the derivative of the second. Again, this is just me deriving the formula for this. Now what we're going to do is we're going to integrate everything in here. So we're going to go through and we're going to integrate this, and integrate that. Okay, so for this first part, when you take the integral of a derivative, you just end up with the original function. And I'm going to leave this as the integral of f prime of x times g of x plus the integral of f of x g prime of x. And the rule is going to be, and again, we're going to solve for this part. Now, why that part? Because that's just what the rule says. We're going to solve for the f of x times g prime of x. So if I solve for that, I'm going to move this integral over to the left-hand side. So I'm going to kind of move it and rearrange everything. So the integral of f of x g prime of x, I forgot my dx is at the end of this, dx is equal to f of x times g of x minus, when I move that over, the integral of f prime of x g of x times dx. And this is actually the rule or the formula for integration by parts. And what you need to notice is that in your original integral, this is what we're going to be given here. The relationship between this is an f of x, this is an f of x, and this is the derivative of that. And the g prime kind of goes, this is g prime of x, this is g of x, and this is g of x. And what you're going to need to be able to do from the very beginning is determine which of these functions you're going to represent with a u, a du, and dv. But again, we'll get to that in a second. All right, and I'm going to show you the rule and then go back. So here's what the rule is. The integral of u times dv equals uv minus the integral of v times du. Now we just did it in terms of f of x and g of x, so I'm going to go back a little bit quicker and integrate it in terms of u times v. All right, so I'm going to go back to here. Let me erase all this. Okay, so now I'm going to do the derivative of u times v, just to show you how this works out. So we u prime v plus u v prime. We're going to go through and integrate all these sides. And when we integrate this side, we get u times v equals the integral of u prime v prime. Second. All right, sorry about that delay. And this is going to have a dx in it. And then plus the integral, I think I said u prime v prime. It's u prime v times dx. And then this is u v prime times dx. And now when I go to simplify this a little bit, we got dx in here. Because u and v, if you look at the rule, they're functions of x. That's why I have a dx at the end of that. So uv equals, now before I go through and simplify this, the derivative of u prime can be rewritten as du dx times v dx plus, this will be u, and dv prime, or v prime can be written as dv dx times dx. And I'm just showing you again where the formula comes from, and what ends up happening over here is this dx and this dx cancel out, so I get a uv equals the integral of v du plus these dx's cancel out, and I get u dv. And if you go and look at actually I got to solve for u dv, right? I'm going to solve for that again. So moving it over and simplifying it, so this is going to be the integral of u dv is equal to uv minus the integral of v du. And again, this is what we're going to start with. We're going to have to represent what u is. You're going to have to represent what dv is. And again, when you represent what u is, hopefully over here you see that that's du. It's going to be the derivative of that. And dv, once we represent what that is and integrate it, you're going to get what v is, and everything's going to have a representation for a u, a v, a dv, a du, and all the other pieces, and you just substitute the values in. Okay? So here we go. Now they give you some guidelines here. It's kind of complicated. It's best just to try an example and show you what happens here. But it says let dv be the most complicated portion. So when you start off with your original integral and you're looking at the functions that are there, let dv be the most complicated part of it. And then u would be the remaining factor. And then let u be the portion of the integrand whose derivative is simpler. Then dv is the remaining factor. And again, kind of complicated, but here I'm going to show you how to do this. Okay? And we're going to leave the rule up here, and it's going to be the same rule every single time. Okay, so again, we're using integration by parts when it's a product of two functions. So my product of my two functions are an x and an e to the x, and the u substitution is not going to work out. So the first thing we want to do is determine what u is and determine what dv is, right? So determine what u is and determine what dv is. And on the last page, we want to make dv the more complicated part of this. So this part here is going to represent my dv, and that right there is going to represent u. All right, so actually let me move this down a little bit. So u is going to be equal to x, which means du is equal to 1, dx, but I'm just going to leave it as 1 because it's going to be taken care of when we rewrite all of this out. Then I'm going to let dv that's a v, dv equal e to the x dx. Now I want to figure out what v is, so I'm going to integrate both of those sides. So the integral of dv is v, and then the integral of e to the x is e to the x plus c. Okay, so now when I use my formula here, the integral of this, the integral of u dv is equal to u times v minus the integral of v du. All right, and now it's just a matter of, here's the formula, take all the things you represented over here and plug them in. And we're going to start right from this part. This is what we're solving for. So that's going to be an x times v, which is e to the x, and we do not need the constant at the end there. So e to the x minus the integral of v, v, which is going to be an e to the x, and then du is just going to be my 1, oh, excuse me, e to the x dx, and the du part of it's just the 1 that's right here. And now all I have to do, now we can simplify this. You get x e to the x minus, and now we can integrate this part. We're capable of integrating that now. So the integral of just e to the x dx is e to the x, and I'm now going to throw my constant back on at the end, and that is the integral answer for our problem. Now, if you wanted to check if it was correct, you could actually take the derivative of your answer and see that it equaled that. And here, I'll do it real quick since you're just watching. All right, so if I want to take if my function was x e to the x minus e to the x plus some constant, and I took the derivative of that, so I want to find f prime of x. And it better give me what I originally had as my integrand. So product rule. The first times the derivative of the second plus the derivative of the first times the second minus the derivative of that, it's e to the x, and the derivative of our constant is 0. So hopefully you can see what happens here is this positive e to the x and negative e to the x are going to cancel out. I'm left with x e to the x, which is what I originally started with. Okay? And again, this all comes down to being able to represent everything as u, du, v, and dv. All right, I'm going to clear that out so I can do the next problem here. Okay, now for this one has a little bit of a twist to it. Anytime there's an ln of x in the problem, that's the part that you want to let u represent. Now again, I know we just said the more complicated part should be the du part of it, or dv part of it. But in this case, ln of x, you always want to make u equal to ln of x. And then du is going to be equal to 1 over x. And now dv, so if we let that equal u, then the remaining stuff has to be dv, which is x squared dx. And I always want to integrate that. So that's going to give me a v. The integral of x squared is x cubed over 3, and then plus c. But again, we'll put the plus c back in. And now you just use the rule from the very beginning. And I'm going to do u times v, so ln of x times v, which is, I'll put this out in front, x cubed over 3, minus the integral of v, which is x cubed over 3, and then du, which is 1 over x. I want to put a dx there. Yeah, I should be putting a dx after that. Okay, and now we leave this part alone, x cubed over 3 ln of x. And now I can integrate that. Actually, let me simplify it first. That x and that will cancel out. So I have an x squared over 3. So that's going to be an x squared over 3. Add 1 to that. Divide. So that's going to end up being an x cubed over 9. And then plus c. And there's your solution. But again, I'm not going to do this, but if you wanted to take the derivative of that, you should end up with what we started with. I'm going to do one more for this video, and then I'll start a new one. Okay. All right, now for this example, I'll just tell you from the very beginning, you're going to have to do integration by parts 2 times. You have to do this twice for this problem. Okay, So u is going to be equal to x squared. Again, this is the whole part of it, is like, what do you make u and what do you make dv? Du would be equal to 2x dx. And then dv is going to be the remaining part, which e to the x dx, which means v is integrate this. So if I integrate dv, I get v, integrate e to the x, I get e to the x plus c. Okay, all right, so now if I go through and I write this out, the answer to this is going to be, so I do u times v, so x squared times e to the x minus the integral of, excuse me, v, which is e to the x, and then du is going to be 2x dx. I just want to rewrite this a little bit. X squared e to the x minus the integral I'm going to put as 2x e to the x dx. Now the issue is when you go to try to integrate this second part again, you can't do it. We don't have a rule for it, it doesn't work, but we do now. You have to do integration by parts yet again. All right, so now for the second part, we're going to do the same thing. We're going to make u equal to 2x, du is equal to 2 dx, dv is the remaining part, that's a v again, which is e to the x dx, which means v, which is the integral of that, is going to be equal to e to the x, and then plus c at the end of that. So now I can rewrite this second part as, be careful here, you got to watch your signs for this. Actually, hold on, let me finish this problem here. This is going to be u times v, so 2x times e to the x minus the integral of v, which is e to the x, and then du, which is equal to 2 dx. Alright, so now I can go back over here. X squared e to the x minus that quantity, which is 2x e, go back. E to the x minus the integral of 2 e to the x dx. And we'll just bring that 2 out in front when we go to do this. So x squared e to the x minus 2x e to the x. This is going to become a plus. I did that again. Gosh darn it. The only problem with these videos, you make a mistake, it becomes an issue. And now I'm going to bring the 2 out in front for this integral, and then the integral of e to the x is just e to the x, and I'm going to put a plus c. And then that is the integral of that. But again, make sure you're putting the quantity here, because it's minus the quantity. It's going to change that sign. All right, so there's the first one done, and I'll do I think we have 4 more examples to do in the next video. All right, see you in a minute.